Welcome back everyone, Patrick here, moving on to another trig limit. So we got the limit as x approaches 0 of cosecant mx times sine of mx. So a lot going on here. Notice that we have a trig function within a trig function. So we got a composite function there. And then we have a reciprocal trig function here. So a little bit more complex than the previous ones we did, but it's actually not too bad. It's actually going to be less algebra than some of the previous examples that we did. Now, if you didn't watch the previous examples, as I've been mentioning with all of these videos, make sure you do before watching this one, because lots of the concepts, lots of these results that we showed the work for carry over to the current example that we're on. So over here, first thing I'm going to do is I'm going to get rid of this reciprocal trig function. I always like to take any reciprocal trig functions, not always, but the vast majority of the cases, I like to take them and convert them so they're in terms of the primary trig functions. And if you remember, cosecant x, that's equal to just 1 over sine x. And it doesn't just have to be x. We can have cosecant of any kind of expression that's going to equal to 1 over sine of that expression. So knowing that, I'm going to take this here and I'm going to rewrite it as 1 over sine of mx. Right? Cosecant mx is the same as 1 over sine of mx using this property here. And then this sine of sine mx, I'm going to actually just keep as is. And what I'm going to do here is I'm actually going to combine these into one fraction. Now sometimes if we have two expressions that are multiplying by each other, sometimes I split them up with this limit, make it two separate limits. But in this case, we actually want to combine these two. So I'm going to rewrite this. Now this is all over 1, so it's like this times 1 and then this times 1. So we would end up having sine of sine mx all over sine of mx. And do you see what we can do here? Very similar to the previous examples. Notice we could do a change of variable to get it into this format here. And what we can do more specifically is we can let theta equal this entire expression, sine mx. Because notice that it's within this bracket, we have sine of that expression, and it's also in the denominator. And not only that, as x approaches 0, here, what's the theta going to be approaching? The theta, notice as x approaches 0 here, we'll have m times 0, which is 0. And then what's sine of 0? Sine of 0 is just 0 as well. So as this x approaches 0, this theta is going to approach 0 as well. And you got to make sure that when you do a change of variable that this is happening. Whatever x value you're approaching in this limit, if you're doing a change of variable to try to get into this format, you have to make sure that that theta is going to be approaching 0 as well to be able to use that property. So for example, if I end up having something like sine of, let's say, 2 plus x, okay, and the limit is as x approaches 0, we wouldn't be able to do a change of variable here for this expression, because if it's the limit as x approaches 0, if this was part of the limit, then notice as x approaches 0 here, what's theta going to be approaching? Theta is going to be approaching 2. Okay, but theta has to be approaching 0. So I haven't mentioned that too much in previous examples, but usually when you're doing this change of variable, whatever this x value is approaching, when you do that change of variable and you're going to try to get it into this format, you want to make sure that that theta, or whatever this variable that you're bringing in, is approaching 0, so you can use that. Right? So just wanted to make a side note of that. So with all of this, we can now, let's continue it here. we can do a change of variables. So this sine mx, I'm going to plug in theta. And then for this x approaching 0, I'm going to plug in this theta approaching 0. So we would end up with the limit as theta approaches 0 of sine of theta over theta. And now notice that it's in this format, so it just equals 1. Right, so this limit here, doing all this work, just ends up equaling 1.